Balanced and unbalanced force. Observe the figure in which keep equal masses in both the pans. The box does not move on the table. It is because the equal gravitational force acts on both the pans when equal masses are kept in them. This means balanced forces act on the box with effective force equal to 0 as these are acting in opposite direction. Suppose on first pan the force acting is F and same force is act on another pan. Okay, so it is F. Okay, but their direction is different, opposite direction. So we take F is equal to minus F and the net force is equal to 0. In second case, if more mass is kept in one pan than in the other, the box starts moving in the direction of the pan in which pan mass is more. When unequal forces are applied to the box on the two sides, an unbalanced force acts on the box, resulting in imparting motion to the box. From this example, you will better understand that when unbalanced force is acts on object will move. Okay, let's understand it by another example. You must play tug of war. Okay, in tug of war there are two teams. When same force is applied by two teams, that time the center of the rope does not move. If the force is more on one side, the rope moves in that direction. This means that initially the two forces are balanced. The rope moves in the direction of higher force when the forces become balanced. So another example, when big grain storage container is required to slide on the ground, it becomes easier if two persons push it rather than one person. Important remember are 1. If several forces are applied on an object in the same direction, a force equal to their addition acts on that object. Second, if two forces are applied on one object in directions opposite to each other, a force equal to their difference acts on the object. And third, as force is expressed in magnitude and direction, it is a factor quantity. So here, if more than one force are acting on a body, then the effect on the body is due to the net force. Let's see effects of the force. When a force is applied on a stationary object, it moves. Its speed and direction changes. That means if object is rest and when we apply a force, its direction changes or speed also changes. That means object is in motion. Second, force is required to stop an object in motion. All of you played cricket. Yes, while catching the ball, you stop the ball. That means initially ball is in motion. Catch it, it becomes in rest condition. So, an object can change its shape due to force. While kneading a dough made from flour, the dough changes its shape when a force is applied. A potter applies a force in a specific direction while shaping the pot. Okay, if we stretch the rubber, that times rubber expands, its shape changes. You know that when we apply force, object changes its state of motion. In the absence of a force, object exhibit a tendency to remain in the existing state of motion. It is a property of matter by which it remains at rest or in motion in the same direction unless force is applied. Okay, so remember one thing, the tendency of an object to remain in its existing state is called its inertia. That's why If object is in rest, it remains rest. Or if object is in motion, it remains in the state of motion in the same direction in the absence of any external force. Let's understand inertia by a simple activity. Take a postcard and keep it on a glass. Keep a coin on it. Now skillfully push the card. The coin straight away falls in the glass. The coin falls in the glass, it is because of the inertia. Is all objects have same inertia? Obviously not. It depends on the mass. If mass is more, inertia is more, and mass is less, inertia is less. As I told, Newton's first law of motion is also known as law of inertia. Let's see types of inertia. There are three types of the inertia, that is in rest, motion and directional inertia. Let's see first, inertia of the state of rest. If an object is rest, it remains in rest unless an external force is applied. Say, an object in the state of rest cannot change its state of rest due to its inherent property. This property is called inertia of the state of rest. Second, inertia of motion. It's related to the motion. If object is in motion, it remains in motion. Let's see. The inherent property of an object due to which its state of motion cannot change is called its inertia of motion. For example, a revolving electric fan continues to revolve even after it is switched off. Passengers sitting in the running bus get a jerk in the forward direction if the bus suddenly stops. Third type is the directional inertia. The inherent property of an object due to which the object cannot change the direction of its motion is called directional inertia. For example, if a vehicle in motion along a straight line suddenly turns, the passengers sitting in it are thrown opposite to the direction of turning.